Okay, my name is Peter Kuo. If you pronounce it status quo, that'll be me. Give me great pleasure to introduce Bob and Alan over here from Silicon Valley. And I first met Bob actually in a barbecue store where we were having a Chinese hot pot. You know, growing up, I always have hot pot in a coal fire stove. So when we cook things, you know, on a coal fire stove, it tastes a lot better. But with the advancement of the pollution that we're trying to eliminate, we have moved to using induction heating stove. So at that barbecue store, we call it barbecue, but it's actually induction cooking stove hot pot store. Then I was complaining to Bob, you know, this tastes a little different from my childhood coal-fired stove. He goes, well, I mean, just like today's electric grid that Victor had just highlighted, is that we will still need to have coal-fired power plants throughout the world. We still have many coal-fired power plants in the world, but he has a solution to bring this, to solve that particular problem. Anyway, long story short, I'm just gonna ask Bob these questions, and we're just gonna have a conversation. So Bob is a serial inventor. There's a difference between a serial inventor and serial entrepreneur. I'm a serial entrepreneur, but he's a serial inventor because he really put his hands on things. And so he's very nervous coming to the stage today. So I told him, just relax, don't worry. We have lots of time. You can just talk slowly and walk through your invention here. So Bob, where does this idea come from, and why you're so passionate about carbon capture?
It was a long, hot summer, and the pollution was everywhere in the air. And then we had a really big rainfall. And I walked out in the morning, and I saw and smelled how fresh and clean the air was. That's when it dawned on me, we can collect the pollution. I am passionate about this because this generation, it is critical for us to solve this problem. We cannot push this onto the next generation. It needs to be done, and done now.
And Alan, what is your reason for getting involved?
Well, we're at a pivotal point in our history, and we all know that we've had challenges with fossil fuels for centuries. And we need to address these issues really aggressively, because we can't repeat our history. We need to move forward. For me, seeing it actually work, I mean, being out there with the small scale concept and seeing the black smoke and the coal burning, and as soon as we turned the technology on, it literally turned clear. So seeing it actually work was really intense and really impressive. And we have to live better, we have to do better, we have to be better.
And this next question is for Bob. Bob, you have mentioned that fossil fuels are not going away. Why do you believe in that?
Because of the increased demand on our electrical grid. With AI, data centers, electric transportation, and the explosive growth of electronics, we need all forms of electricity now. The United States has the largest coal deposits in the world. Clean, beautiful coal, more than any other country in the world. If properly filtered, coal can be the next green energy.
So let's talk about that, Bob. What is about Caldwell innovations, that carbon capture technology that can make coal the next green energy?
By reducing the emissions from coal-fired power plants, pollution can be eliminated.
And the effects of the pollutants are currently causing extreme weather fluctuations throughout the world, and that also creates a large demand on our energy. With carbon capture technology, we're able to filter directly at the source, which forms abstracting molecules, creating consumable products. With these technological advancements, we're creating jobs for our citizens, a stronger economy, more dependable, reliable, and renewable energy, and a defensible mechanism for the Earth to begin to heal itself.
So, best to my understanding, Bob, there are currently 3 methods of carbon extraction. Number 1, carbon capture storage. Number 2, superficial plants. Number 3, coal gasification. What do you think this work in the world that we live in today? This won't work, actually. Why won't this work? Sorry.
CCS contaminates our water aquifers, and there is no real guarantee that the carbon will not escape into the atmosphere. Supercritical plants like those in Australia, have shown higher breakdown rates and are less reliable than older coal-fired power plants. CG requires more energy and water. It is an intensive process that is very expensive. Caldwell Innovations' carbon capture technology is not only an environmentally friendly option, but also an affordable, sustainable technology. The technology can remove pollutants before ever entering the air that we breathe. There is nothing used within the process that this technology that is toxic other than the pollution itself, which is captured into a transferable byproduct that can be used for profit. Pollutions to profits.
Interesting. So, Alan, what are some of these uses for the captured carbon dioxide?
Well, we've got fertilizer. CO2 can definitely be used as fertilizer, which is in a world shortage because of the war in Ukraine and chain demands. There's also another example, carbon nanotubing, which is 100 times stronger than steel. It's lightweight. It possesses high electrical and thermal conductivity, and it's also flexible. This makes carbon nanotubing an option for many possibilities, such as aerospace, electronics, and also medicine. And one point I found very interesting, and another reason that I kind of joined the team, was the advancements in medicines. It can target specific cells or tissues. It enhances drug effectiveness, reduces side effects. It's also being explored for cancer, and something very near to me is Alzheimer's. My grandmother passed from Alzheimer's at a very young age. My mother is in a memory care unit, and I'm close to 60, and every time I forget a word, I panic. So using carbon nanotubing for all these medical advancements is just huge to me.
Wow, that's fascinating. And I say that in a very, because my dad just passed from dementia not long ago. Okay, so boy, sorry.
Sorry.
No, we
I'm
can all
very
agree.
Broad emotions.
Yeah, we can all agree that there are different challenges in today's method of polluting containment and control within the coal-fired plants. But with these challenges, doesn't that bring a lot of opportunities?
Yes. Caldwell Innovations' patented carbon capture technology provides a sustainable process at the source, the power plant, that reduces up to 95% of the pollution caused by fossil fuels entering the atmosphere. Our mission is to see this technology on as many as 1,400 coal-fired power plants, thus preventing approximately 20 billion tons of pollution from entering the atmosphere. Allowing the earth its natural ability to heal itself. Whoever controls this technology will have the opportunity to make the coal industry more sustainable and the potential to generate future consumable products, creating pollutions to profits, such as fertilizer and carbon nanotubing previously mentioned.
So there are 3 major components of the pollutions that are pouring into our air supply. There's carbon dioxide, sulfur dioxide, and nitrogen oxide, excuse me. So Bob, how does this technology work all together?
Well, let me start by saying carbon dioxide is elusive and difficult to capture. It almost thinks for itself. This elusive, clear, and odorless gas was the most challenging component to encapsulate. I had to provide the perfect environment. Once the intake tube is operably connected to the power plant, it draws the pollution into the cooling tube. By reducing the temperature of these pollutants, especially carbon dioxide, it changes from a gaseous state into a liquid state called droplets. These droplets are then entering the U-tube. The U-tube was a gauntlet of misters. The droplets then bond with the water from the misters and become heavy. Then they drop to the bottom of the U-tube where they are trapped, filtered, and then put into the back of a truck or train and prepared for delivery to the factories. This process includes electrolysis, and the cohesion of these molecules result in a stable association to be later used for potential products, pollutions to products. Making this profitable is key. In our small-scale proof of concept, we were filtering at approximately 400 to 600 cubic feet per minute of pollution. Because of the
Okay. So we are going to be out of time very soon, but last thing, I just want to sum it up a little bit. So what we do is capture the carbon dioxide in a U-tube, it's called, and this is the actual byproduct of this capture, and this powder, the CO2, which eventually become carbon nanotubing. It's usually costs between $3,000 to $10,000 per pound, and so the output is actually steam mist from a coal-fired plant. And finally, do we have a patent for this technology?
Yes, we do. I did want to mention that we can sell the carbon dioxide as fertilizer, which sells for approximately $400 a ton, and we are pulling out about 1 million tons from a smokestack per year. That's $400 million, more than pays for this technology to be installed.
All right. Great. Thank you so much, Bob. Appreciate that. All right.